Okay, students. So when we will combine both half reactions, then we will get the overall reaction. Then we will get the overall reaction. Now you should know about the oxidation half reaction and reduction half reaction. So oxidation half reaction is, tell me about that. Oxidation half reaction. Yes. The zinc is converting into the zinc ions after losing two electrons. After losing two electrons. And students, reduction half reaction is, yes, copper ions converting into copper metal after gaining two electrons. Then students, we will add both of the reactions. We will add reactant into reactant and product into product. Then students, you can see here reactant is zinc plus copper 2 ions plus electrons. Students, here 2 electrons removal is taking place, but same electrons are gaining by this copper ion. So we can cancel them. We can cancel them. So here you can see Zn2 positive plus copper. Now students, how can we represent this cell? How can we represent this cell? During representation of this cell, you will write left hand side oxidation half reaction and right hand side reduction half reaction. So we can write the reaction in this way. In oxidation half, zinc is converting into the zinc ions. Zinc is converting into the zinc ions. And in between this one, what is this? This one is the salt bridge. This one is the salt bridge. We are connecting both the half cells with the salt bridge. So this one is the symbol of the salt bridge. Okay, then students, salt bridge is separating two half reaction, oxidation half reaction and reduction half reaction. So in left hand side we will write the oxidation half reaction and in right hand side we will write the reduction half reaction. And in reduction half reaction, copper ion is converting into the copper. So copper ion is converting into the copper. So this one is the representation of the electrochemical shell. This one is the representation of the chemical shell. Okay, so students, how will you represent? You will first of all you will write oxidation half reaction, then you will write separate with salt bridge, then you will write the reduction half reaction. Okay, and students, some potential is generating between these two half cells, that is known as the potential difference, that is known as the E naught cell, and the maximum potential difference between these two electrodes is known as the EMF, electromotive force. And students, here we are making the setup of this cell at standard conditions. Standard conditions means temperature 298 Kelvin, pressure 1 atmospheric. Okay, and you know very well, already we are taking the concentration fixed, that is the 1 molar concentration. So at STP we are doing, we are setting this, we are making setup of this cell. So students, here which potential difference we will calculate, that is known as the standard electrode potential. How can we calculate the standard electrode potential? Clear or not? Then students, here the potential difference which will produce here in right hand side and in left hand side. Okay, then we will write in this way. E naught shell is equal to E naught cathode minus E naught anode minus E naught anode. In this way we will calculate. So students, we were having the shell zinc converting into Zn2 positive. Okay, and students, here you try to understand. Here copper is converting into copper. Copper ion is converting into the copper. You know very well, this one is the left hand side. This one is the left hand side. This one is the anode. And student, this one is the right hand side. And this one is known as the cathode. So student, for this, we should know about the electrode potential for that. Okay, so we have table for that. For that we have table. Okay, so for this students, you can see here for copper, this one is the SRP. SRP means standard reduction potential. Here this table, here only reduction potentials are given to us, not oxidation potential. But students, if we know about the reduction potential, then we can calculate oxidation potential also. How can we calculate? Let's see about that. Here E naught reduction is equal to minus E naught oxidations. Means you will change sign only. You will change sign only. After changing the sign, you can convert reduction potential into oxidation and oxidation into reduction. Clear or not? So here reduction potential for copper, this is 0.34 volt. 0.34 volt. And student, second one, we are having zinc. For zinc, this one is minus 0.76 volt. Okay, then you will put the values for this. Then students, E naught cathode. At cathode, copper half cell, reduction half cell is there. So this one is the reaction. And for copper, you can take when ions are converting into the metals, means they are gaining the electron. And if they are gaining the electrons, means reduction is taking place here. And reduction potential we know very well because we are having table for that. And for that, what is the value? This is the 0.34 volt. Okay, volt is the unit for potential difference, students. So you can put the value minus. Now you will see E naught anode means reduction potential of the anode. So here for zinc it is given as minus 0.76 volt. You will keep this value 0.76. Now students, what will you get? 0.34 plus 0.76. After adding, what will you get? 1.10 volt. So this one is the standard E naught shell, standard reduction potential of the electrochemical shell. Electrochemical shell. Student, this is the process. How can you calculate? But sometime directly can be asked. So you will keep in your mind the standard electrode potential for electrochemical cell is 1.10 volt. Clear or not? So how can you, if other cells equations also given to you, so how can you calculate the standard electrode potential for that? Okay, values will be given to you. Okay, you will get values. Then student, you will put this formula. E naught cell is equal to E naught cathode minus E naught anode. Clear or not? And students, sometime if oxidation potentials values are given to you like that, maybe you have value Cu converting into Cu2 plus is equal to minus 0.34. You need not to be worried. Here metal is converting into metal ions. Metal is converting into metal ions. Means it is showing oxidation. Because metal convert into metal ion after losing the electron, and loss of electron is known as the oxidation. Means students, here oxidation takes place. So this one is the oxidation potential, not reduction potential. But if you know about the oxidation potential, then you can calculate reduction potential also by changing the sign only. Then what will be the reduction potential? Reduction potential Cu2 by Cu is equal to 0.34. Clear? In this way you can convert the value also, and you will apply this formula, then you will put the values, and after putting the values you can calculate the standard electrode potential of any cell given to you. This topic is clear to you? Okay, any doubt? Okay, so thank you, have a nice day.